Hi friend, in this series we will discuss Renesas RL78 timer and its programming in CS IDE. For the detailed study of the timer, let's open the hardware manual of that particular series which you are using. I am using the RL78G13. Open the timer. Let's see how much timer is available for this series. This timer array unit having a two unit 0 and unit 1, but this unit 1 is available in the higher pins only, 80 pin, 100 or 128 pin. Unit 0 is available in all the pins, pin 20 to pin 128. And this is channel 0 to channel 7, and this timer is a 16-bit timers, and it's having two types: independent channel operation function and simultaneous channel operation function. The independent channel having a few types. First, like a interval timer, square wave type output, external event counter, divider, input pulse, interval measurement of the high and low width of the input signal, delay counter. And in simultaneous, having the one shot pulse output, PWM output, multiple PWM output. This PWM we'll see in next video. In this video, we'll discuss interval timer. Okay. This function having first one is an interval timer. Interval timer is mean each timer of the unit can be used as a reference timer that generates the interrupt at a fixed time. Means this interrupt is generated or interrupt at a fixed interval. As you can see in the clock diagram, this is the operation clock is given to the channel 1, channel N, and compares the operation, and it's generate the interrupt signal INTTMmn. Second one is a square wave output. This square wave output, a toggle operation is performed in this, and interrupt is generated, and the square wave is the duty of the 50% output of the timer pin. So this square wave you can see or you can generate on the any output pin. It is a particular pin which controller is supporting. And third one is an external event counter. In this external event counter, that generates an interrupt when the number of the valid edge of the signal input to the timer pin. Any valid edge is when you can give on this pin, this interrupt or this generated. Second one is a divider function. For fifth one is a input pulse interval measurement. You can measure any external pulse, you can give here, and we can measure that one frequency. Here input sixth one is a measure of the high and low width of the input signal, and seventh one is a delay counter. Here they have given everything, and here in that configuration settings, configuration of the array, it is there, it is given in the hardware manual. The control system, peripheral enable timer clock, and register. These are some basic registers used to control the timer or setting the timer. Okay, we'll see in this one, this some registers in the software. Okay, so open the program in, open your CS IDE. Let's quickly create the one project. Select your MCU, then timer, interval create. So we already know how to create the code using this code generator. So quickly I am generating it. The open code generator, fix this setting, clock setting. I am setting 2.7 to 5.5 and select on chip debug setting. If you have the hardware, then you can use the on chip debug setting, use here, or you can directly use. And I'm not using the watchdog timer here, so unuse that one. I'm using the timer. Okay, now let's see the timer in the code generator. Open the code generator timer, and here as you can see, this RL7800 LE, it is a 64 pin MCU, so it is supported only the unit 0. As you already know from here, it is supported only this 7 channel. Okay, so channel 0, here is an interval timer, square wave timer, dividend function, external event counter, input pulse, PWM, and one shot. As per what you are going to select, it depends on you. Here channel 0, we are selecting like a suppose interval timer. So this one is, this channel 0 is open. Now here you can see interval timer setting. This timer having a 16-bit timer, and here is a setting of the how much time you want to set. You can set here, and these are a unit of that one. Okay, now suppose I want to set the 1 second time. So to set the 1 second, we know 100 1000 is equal to the 1 second, correct? So here set the 1000, and here is the option. You can set 1 millisecond, 1 microsecond, or nanoseconds. That depends. I have to set the 1 second timer, so I am selecting 1000 millisecond. So this no need to worry about this. Generates the input when the counting is started. When it's generated, this interrupt is generated initially when the counter start the counting, and this is an interrupt when the fix the whatever we have set at the time, that one interrupt is generated. After this interrupt will generate. Okay, so that's all the setting of this, and this one is a priority of the your peripheral. Here is a generate code. Once the code is generated, you can see it's 3 file is created: timer 0, timer.c, timer user.c, and timer.h. Timer.h header file, there is some declaration is given in HT file, and in below you can see the 3 function like create, start, and stop. Okay, so this is available in the timer.c. This is a create function, this is a start one, and this is stop. For the details declaration, once you create the project, you can see in that it is a peripheral on, so it is a timer on, timer array unit 0 enable, then timer clock, selection register, and these are our mask channel intro channel 0 to channel 7, and this is a priority we have they set here, and these are main setting of our channel. This is a timer mode register. So when you can see here the clock is set, then this is a triggering for the timer is software trigger, and here is a mode we are using. This is a interval timer, so for the set interval timer, and this is a time, or you can say our TDR is a timer data register, this timer output register, and in timer output enable register. Okay, we have enabled the output now. So to start the timer, we have to call this function in your application, and this is a stop when we have to stop the timer. Now I am going to start my timer, so copy that function, comes in your main file, and copy paste. As we know, to start our writing the code in this start user code and end user code to code safe. Safe means after generating a code, maybe it is guaranteed sometimes your code will be vanished that time. So to write your code in between only the start user code and end user code. Okay, now my timer is started. So after every 1 second, 1000 millisecond, my timer interrupt is generated, and this interrupt is written in the timer underscore user.c file, and here suppose I am setting a flag, so every 1 millisecond my timer will increase. So this flag will increase. Okay, build, here is some option, build a code, rebuild the project, build and rebuild. Now my code is built. If you have a hardware, this is our code is set up for to check the timer. Okay, so here suppose you have a hardware to check this code, then in RL78 debug tool you can right click on it using the debug tool, and you can select the emulator which are using. Currently Renesas has absoluted this E1, so if suppose you have E2 Lite, then select the E2 Lite or E2. Okay, so I am using it on the simulator, so keep it as it is. But the down here is a download option, but like suppose what I am going to tell you, okay, if you are using the simulator, the timer counting, whatever the increasing the counting, it is really slowly increasing, very slowly, as your current 1 millisecond time. So if you are going to compare it, then it really slow that time, so don't compare here. So only we will check here whether our code is working or not, or this timer flag is increasing. These are some executable, and run the program. Once you run the program, as I told you, this timer will increase very slowly, this flag, because in simulator the clock is given whatever, it is really slow, that time is counting going to very slow. If suppose you have a hardware, then you can download it on your hardware, or you can test. Okay, so our code is working, code and our timer, whatever I have set, it's increasing or it's working perfectly. For any query, please let us know, and thanks for watching this video.